Welcome to today's live webinar, Engineering a Data Mesh that Benefits Business and Technology. I am Chris Twogood, SVP of Global Marketing at Teradata, and I will be your moderator today. We've come together today to take a real-world approach to what it means to implement a data mesh. You're going to find out why innovative companies are deploying data meshes in their environment today. During this session, you'll learn a number of key things. First off, you'll learn what is a data mesh and why do you need it. You'll learn how your organization can drive a lot more agility with data and analytics with a data mesh. And we'll talk about some best practices for successful deployment. I'm excited to introduce our panel of experts today. First off, we have Ron Tolido. Ron is EVP and CTO of Capgemini's Insights and Data Global Business Line. He is also a certified master architect and leading the AI futures domain for the company. Ron is a lead author of Capgemini's widely acclaimed TechnoVision Trend Series and editor-in-chief of the data-powered Innovation Review publications. He is an executive lecturer at several Dutch business universities. Welcome, Ron.
Thanks, Chris. Greetings from Amsterdam.
Yeah, greetings from San Diego. And we also have Claudia Imhoff. Claudia is president and founder of the Boulder BI Brain Trust and Intelligent Solutions, Inc. She's a thought leader, visionary, and practitioner in the rapidly growing field of business intelligence and customer-focused strategy. Claudia is a popular and dynamic speaker and internationally recognized expert on data and analytics, and she's a friend of mine. So welcome, Claudia.
Well, thank you, Chris, and thanks to Teradata, and welcome to from Boulder.
And to round out this exciting panel of experts, we have Stephen Brobst. Stephen is the CTO for Teradata, and he's widely regarded as a leading expert in data warehousing. Stephen performed his graduate work in computer science at MIT, where his master's and PhD research focused on the foundation of high-performance parallel processing. He also completed an MBA with a joint coursework and thesis from Harvard Business School and MIT Sloan School of Management. Stephen is a TDWI fellow and has been on the faculty of TDWI since 1986. Stephen has been ranked the number 4 CTO in the US and has authored a numerous set of journals and conference papers. So welcome, Stephen.
Thanks, Chris. Am I not your friend?
Yeah, you're my friend. Yeah, Ron's my friend, Stephen's my friend. Yeah, absolutely. Everyone's my friend. So we're excited to have this group of really dynamic experts together today. And by the way, we want this session to be interactive. So we encourage you to ask questions. Please be sure to submit your questions through the chat portal. I will be moderating them during the session today, and I will introduce them to our panel of experts throughout the session. And if we do not have the opportunity to get to all of the questions, be rest assured that we will follow up after the session. So let's jump in and let's start talking about data mesh. Stephen, let's start with you. I mean, I'd like for you to kind of kick things off for us and share really what is a data mesh. This might be a new concept to a lot of people, and why do you need it? Can you spend a few moments on that?
Sure. This material is actually based on a paper that Ron and I co-authored a little bit ago, and also based on some of the groundbreaking work from Dagani at ThoughtWorks, who sort of conceptualized a lot of the data mesh foundations. So let's go to the next slide, please. So we look at the goal of data mesh. The main point is to align processes and focus on data products. Can we go to the next slide, please? Are we not getting the next slide? Yeah, there you go. So this concept of data product is important because I think in many organizations we have this terminology, data is the most valuable asset, and we focus on assets, and we accumulate assets, we put them in warehouses, we inventory, we count them, we measure goodness by how many bytes they are, and this is really the wrong approach, in my opinion. We need to focus on data as a product, meaning that it's consumable and it's aligned to business value creation, it's discoverable, et cetera. So a data product mentality is different than a data asset mentality. And data products can be, of course, analytical, which is our focus, but analytical can also be operational. A lot of decisions that you make are operational. And one of the primary goals of data mesh, in addition to reoriented to this product approach, is driving agility, right? Avoiding over-centralization of governance and implementation that create bottlenecks. So let's go to the next slide, please. And when we look at the practice of data management and data warehousing in particular, I would argue that we've been a victim of our own success. In the beginning, we needed to centralize resources because the expertise and how to build a data warehouse was rare in an organization. You needed subject matter experts that we wanted to bring together. But that's not really the case anymore, right? We don't anymore have to argue about why a company needs a data warehouse. We know that people need access to information for decision making. And in fact, there's been an explosion of the number of data consumers. On the right side, you have consumers from all parts of the business, all levels of the business. We talk a lot about data democratization. On the left side, the number of data sources that we care about, both internal and external, has grown exponentially. And in the middle, a centralized team, you're caught between a rock and a hard place. You cannot be successful in meeting the exponentially, exploding demands of consumers and exponentially exploding influx of new data sources if you're centralizing everything. So we need to decentralize in order to deliver more quickly. So this agility is a really important theme in our discussion. So we're gonna break that practice of centralizing the team, but try to do so in a way that we don't create anarchy. So let's go to the next slide, please. So there are three main principles, and this is taken from Degani's work published some time ago. First principle, and I mentioned this one already, the focus is on business value. The focus is on consuming data as a product. It's not about accumulating data and archiving data, and it's about this goal of business value driving how teams are organized and about driving data architecture. In fact, I'm going to argue, and Ron and I have this discussion in the paper that we co-authored, data mesh is not about technology. Data mesh, in fact, is as much about organizational structure as it is about architecture. And so, if we look at Conway's law and we understand that architecture is very much aligned to human organizations, this is an important theme of the discussion. And understanding the implications when we distribute responsibility. So we create these loosely coupled teams where we decentralize a lot of the decision making that allows us to move more quickly. But aligning these teams to business domains. So we have context within boundaries, and we have ownership of data by the subject matter experts that drive the processes within the business, right? Data is created by business processes. And this is an important point because sometimes people get confused when we talk about distributing responsibility. They'll align to different subject areas of data, right? Data, party and agreement and event and so on. And that's actually not what we're talking about. We're going to align to business processes because these different subject areas in the traditional approach for building a data warehouse, they require too much centralization in the data modeling and the provisioning of data and so on, because many different business processes create data that align to these different subject areas. So we need to figure out how to decouple in order to be successful and to be agile. So we look at, how we're going to implement aligning domains to schemas. So now I'm getting a little bit lower level of detail in the technology and the engineering, not to specific technologies, but a way of thinking about how do you physicalize this, right? We have schemas which contain the data aligned to a particular business process. And we're going to have the detailed data model design, the provisioning of data into the schema, the ownership of quality and stewardship. This is going to be aligned to business processes, right? So subject matter experts are in the business processes. These domains are going to operate in a relatively independent way, right? And that's where we get the agility. Loosely coupled teams has lower friction and driving fast time to market. On the other hand, we don't want anarchy, right? So many data warehouse teams are, I would say, over-centralized, and that creates friction in the ability to move quickly. But complete distributed with no enterprise governance is anarchy, and we don't want that. But what I'm suggesting here is a light governance approach. So, we want some level of centralization for example, provisioning infrastructure. We don't need every single team to figure out how to do that. Enterprise security is something very important. And there are other areas where the enterprise capability is important, but a light hand in governance rather than a heavy hand in governance to allow more agility and more innovation. Next slide, please. So when we look at the implementation of the capabilities that we're talking about here, that agility is absolutely critical. Let's go to the next slide again, please. We want the agility, but we also want to avoid a collection of isolated schemas. So if each decentralized team builds out its own schema in their own little silo, then each one of those schemas will have value, but it'll be equivalent to essentially an independent data mart. And independent data marts do have value, but they don't have as much value as if you can connect across the multiple schemas. So this is, as part of governance, you want to make sure that you've got integrity between the primary and foreign key relationships. And if you've got these n schemas, and if we connect them, that gives us n squared connection points and n squared value. So the connections and the level of governance required so that you have consistency in how we generate surrogate keys is important. This is part of the engineering discussion that we're going to facilitate in today's workshop. Next slide, please. When we talk about how to deploy the schemas, I already mentioned having a collection of isolated schemas is not the ideal scenario. So we want to connect the schemas, but there are different ways to connect the schemas, right? We can connect them in a co-located environment. From an engineering point of view, co-located means under a single database instance in a single infrastructure that optimizes the physics, right? It means less data moving around. It means lower cost and egress and ingress fees and so on. But the reality is that putting all data in a single technology, in a single database instance, it's not practicable for large, complex enterprises. The reality is, because of sovereignty laws, you might have in an international organization, different data will need to live in different geographies. When using fit for purpose approach, you'll have different technologies for different purposes. You might use a document store for certain semi-structured data and a relational store for other kinds of data and a graph database for yet other kinds of databases. So there will be different schemas, even in different technologies. We still need to connect them. This I would refer to as a distributed set of schemas, and technologies are required in order to bring the connectivity to the reality of the consumer of that data product. So we're going to have, a combination of co-located schemas and distributed schemas. That's the reality of the real world. And making good decisions about how to engineer those is important. And hopefully as little as possible in the area of isolated schemas. Let's go to the last slide, please. So just to summarize some of the key points, the purpose of our discussion today is to challenge some of the status quo that was born in the early days of data warehousing with, big bang implementations with centralized approaches to implementation. We'll talk about domains versus subject areas, the point that I raised earlier. And remember, our goal is to drive innovation with more agility. And to do that, we need to decentralize, but we need to also take into consideration, good engineering practices. Figure out when you want to connect and co-locate versus when you want to collect and distribute, and have appropriate levels of governance. So I'm going to end there on the Burning Man slide, which for me is a representation of innovation at its best. And I'm going to turn it back over to Chris to discuss the main content of the workshop. So back to you, Chris.
Yeah, thanks for that, Stephen. It's interesting. It feels like there's always been this battle, right? There's a battle between agility but not wanting anarchy. There's a battle between governance and non-governance. There's a battle between centralized and decentralized as a core foundation. But I like what you said. There's got to be a solid engineering approach to how this gets implemented. I mean, Ron, can you spend a few minutes and really kind of talk about and explain what are the critical components of a successful data mesh, and what are some of the challenges that you've seen in developing that engineering approach and also operationalizing it? Can you talk to us about that?
Sure, Chris. I do think we all agree, and Stephen made that point already, that it's definitely not about technology, although I would say that technology nowadays enables us to do things, for example, in terms of high levels of automation and high levels of maybe AI augmented self-service. We can do things that we thought, that we may have thought of before, even in the past decades, but we're never able actually to pull off, right? And it's the same what we've seen in software engineering as well. I have a bit of a mixed background, both in data, but also in software engineering. I always tend to think that on the software engineering side, we tend to find out things a little bit earlier. Like the whole DevOps movement, of course, which is also unthinkable without the help of highly automated tools chains, right? Highly automated technology to support it. Having said that, that's not the critical component of it. It's an enabler. I think many people agree that the whole notion of domain ownership, and with that comes also, by the way, responsibilities, which sometimes is forgotten. I think the whole notion of ownership of data by the domains, not necessarily, by the way, just business domains, but could be any let's say, also more horizontal domain that for example, aggregates data and adds something to it, and on itself creates a new data product. I think the ownership by data domains is an absolutely crucial component over here. And it sounds like, yeah, sure, we'll sort of move control to these domains which are much closer to where the data actually comes from. So they're supposed to pick it up, right, and then turn it into a product. But obviously, if you discuss this, for example, with a chief data officer or a CIO or a main data architect, lead a data architect, you're actually telling them, hey, we have great news. You're going to get rid of many of the things you currently do and all the responsibilities and ownership you have, and we're going to hand it over to other people in the organization. Isn't that great? And then there's crickets and silence, and it's a bit of a. So that's a very massive cultural shift, which I think is essential to the notion of data mesh. And then the other one, already rightly mentioned by Stephen as well, of course, the notion of product management. I love that. Data is not an asset because you just stack these things and you put it on your balance. Who cares? Really interesting is how do you make it into a valuable first-class product? And that is, of course, the responsibility of the domain. So there's the exchange, right? Hey, we give you ownership. Oh, great, we want it. But then, oh, wait a minute, there's a catch. You have to You have to manage that data as a product and make it available as a first-class, high-quality product to other parts in the organization, to the other peers, the other domains, the consumers also that want to, of course, consume that data, for example, for analytical purposes. And product management really is a different ballgame. That is about not just managing a product, it's about creating a compelling experience for all these data consumers. Any product manager knows how to apply design thinking. What does the data consumer journey looks like in all these different personas, and how can we make it fluent, exciting, compelling, so that you want that product, right? And you get more hits on your data mesh product. So I think the notion of product management is another absolutely crucial one. Combine it with this domain ownership, and I think you have two of the absolute key dimensions of data mesh, and then technology, of course, needs to enable it. And there is this governance that Stephen alluded to as well. But I believe it all starts with the notion of domains.
And I like that. I like that, Ron. I think the core foundation of domain ownership and being able to have, the data, and as Stephen said, the business processes closer to where the data is generated and the users that use it is really important. I also liked what you said about this idea of it's not just about technology, right? It's also about culture and taking ownership and, being able to think about the social aspect of this. Claudia, what are your thoughts about kind of the cultural aspects of data mesh?
Yeah, well, first of all, thank you, Chris, for the question, and thanks to Teradata for letting me play. I've said for years that the technology, we can put the technology together. We're great at that. We can build all kinds of wonderful technical architectures and everything under the sun. Our Achilles heel, if you will, is that the culture has to accept it. And the culture of an organization can be a death knell if people don't understand what analytics is all about, don't even understand how to use them, how to create them, how to manipulate them, whatever it is. They're going to look at all this beautiful stuff that we've presented out in front of them and go, nah, not interested, give me my spreadsheet. And it's just, that's heartbreaking in some ways. So I think for me, one of the problems is moving the culture into that wonderful nirvana where they are analytically driven or data driven, if you will. Data literacy is now throughout the organization. It's not just in the hands of a few. So I think part of that's going to start with education, not training, education. We can train them on how to use a tool. We need to educate them on what analytics is, how they use it, when they use it, why they should use it, and how they share it, and so forth. It's even more than that, though. It's also the ethics on using it. We're now moving into an area or a time frame when we need to question, should we be doing what we're doing with our data and our analytics? Is that ethically and morally right? And I think Ron mentioned so many other aspects, and so did Stephen. The governance, the security, the privacy issues, and so forth, those don't go away. And those are not necessarily, technology helps us certainly, but especially in the area of governance. The other thing I might add is the ability for someone. I know that in working with my clients, one of the biggest frustrations I hear from the business person is that they don't know where to find the data, how to find the data. So in some respects, another added piece to the mesh may be something like an analytics or data marketplace, some way that they can actually tap into what's there, find what they need, see that they don't have to reinvent the wheel, and understand how to use this environment. So a marketplace, or whatever term you want to call it, maybe it's a part of it is a catalog where I can find the data and so forth. Those are things that are outside of the overall technological underpinnings, but certainly are key components to the overall usage of this environment now.
I like what you said, Claudia, because if you don't give them the right training, right, if they don't give them the right kind of capabilities to find data, then they're just going to drive towards anarchy, and they're just going to say, hey, I'm going to go back to my spreadsheet. And so I think making sure that when people think about a data mesh, they think about, okay, how do I implement this with different design patterns, but also how do I make sure I build into it, the education? I guess, Stephen, what's a little bit still not clear to me, you talked about these different types of design patterns, right? You talked about this connected and co-located, or co-located and distributed and isolated. Does somebody just pick one of those and then deploy that throughout it, or is it a combination of all three of those? Can you talk a little bit about how they should think about it from an engineering perspective, about what design patterns and how do they build out their schemas?
It's absolutely a combination of those things. So if you look at, if you have all the schemas co-located, then basically you're saying that I'm minimizing data movement, I'm minimizing ingress and egress costs, I'm allowing the optimizer of whatever data management platform you're using to get full visibility and to get better performance and so on. So from an engineering point of view, co-location is certainly desirable, but it's not realistic for all scenarios. Right. So you can, if you look at only the physics, yes, of course, I want co-location, single optimizer, and so on. But when you look at, the bigger picture of, I want to be working across multiple clouds. More than 80% of the organizations, at least that I work with, large enterprises, they have a multi-cloud strategy. They're not going to have all their data in a single cloud necessarily. And so we need to be able to connect data across multiple cloud platforms. And when I say connect, there's two levels of connection. There's the level of connection of, did I do the appropriate governance to have consistency between the primary and foreign keys across the multiple schemas? Can I connect them logically? Once I can connect them logically, and that's really the prerequisite, then I have to be able to connect them physically. If they're co-located, connecting them physically is quite straightforward. If they're distributed, that means I'm across multiple clouds. And now I've got to bring data together across, AWS and Azure and GCP and maybe on-prem as well. I might need to bring data together, across different technologies. So I'm using a graph database to represent an organizational structure, and I'm using a relational database to collect all the transactional data, and I need to bring those together so I can understand how to roll up commissions based on the transactions that have happened with the customers and so on. There needs to be a piece of software. So of course, there's hardware as well, but there's a piece of software that needs to bring these things together. And there is a cost to doing this. And really a critical piece is, from an engineering point of view, bring the processing to the data, don't bring the data to the processing. In other words, if I can, from an engineering point of view, if I can have the engine that has the data do as much of the filtering, the projection, the pre-aggregation as possible, that optimizes the overall cost and efficiency of the solution. And again, we're getting into some detailed engineering discussion, but it's a reality of most organizations that yes, the bias will be towards co-location. Now remember, co-location still allows you, and I would still encourage you to have multiple schemas with decentralized ownership, right? So data mesh, as a concept is about, decentralized ownership of these schemas so you can move quickly and so on. From a technology point of view, data mesh is not taking a position. It should be able to work whether you are in a distributed environment or in a co-located environment, right? As long as you've got the logical design in place with those connection points. And then, of course, then there's the engineering. If it's distributed, you have to have a little bit more work done to get the processing and bring the data together and so on, potentially across clouds, across technologies, and so on. But the bottom line answer to your question is it's a combination of connected and co-located and connected and distributed. Now, I put isolated there because it's a reality of some organizations, but my experience is isolated mainly has to do with politics, not technology. That someone is hoarding data and it's my data, I don't want to share it, and the anarchy goes a little bit too far in sort of distributed ownership where they're not willing to share. So I want distributed ownership, but I want sharing, and so this is a critical piece.
Yeah, no, I like that, Stephen. It feels like, it's not one or the other, right? That you want to look at co-location, for performance, but this is why you have to engineer it. You have to think about, do I need performance, or is it better to have it in a distributed environment? What I really liked about what you said is that whether you do centralized or decentralized or distributed, you absolutely still give the domain ownership. Hey, I wanted to let you guys know that we've got a really good crowd, quite frankly, from around the world. We've got folks from Egypt and Saudi Arabia and India and the Americas and Pakistan and Argentina and Mexico. So people are saying greetings to everyone. In fact, we've got a question that came in here, and I'll give this to you, Ron. I think this is a really good question, right? If you decentralize the data ownership by giving domain ownership, how do we ensure that everyone's following the same data definitions throughout the organization, right? That can become the challenge. It feels to me like that's the difference between data mesh agility and anarchy. What do you think, Ron?
Yeah, and it's a good point, and it touches on the fact that this autonomy from a business domain perspective and being able to own it yourself comes with a comes of course with a balance that you need to maintain. And I think it's very clear that the whole notion of open standards and a platform that you all agree on, which you use to actually exchange and collaborate that data, that's a crucial one. So that is the price, if you like, that comes with it. Because otherwise, indeed, if we're all speaking our own language and we're all minding our own business, which is good, but we're not able to exchange the thing. I thought Stephen made a very important notion just now, and it also was building on Claudia's mention of a data marketplace. If everybody keeps the data to themselves, it's not a product. It's not something you want to exchange with others because you want to keep it to yourself. So it's not a product, right? So product management comes with, let's say, performance indicators, horrible words, but it's true anyway. You want to see how many people actually use your part of the mesh, right? How often they are using it, how enthusiastic they are about it. So you want it to be, you wanted to have all the characteristics of data that is accessible, right? That is visible, findable, if you like, which is interoperable, which is reusable, which are of course pretty straightforward. The FAIR principles are very well known. You want to comply to that. You want to adjust to that, because otherwise you'll have that anarchy. But what's the point anyway of managing it as a product if nobody's using it? That's of course death, right? You set up a product and nobody's interested in it or can find it or is able to connect to it and use it as a consumer. Or maybe another domain that wants to use the data to aggregate and create something entirely new that they want to sort of put on the marketplace as a product, right? So it's a very good question, and it comes with a price. So this autonomy, this domain ownership, comes with the price of having to adjust to open standards, which is something, of course. I mean, look at the entire internet, very autonomous, and having said that, based on very clear, established open standards. So I believe that's a balance act. And again, we do have nowadays the means of technology to enable this probably a lot better than just a few years ago, which also explains why we see the breakthrough currently.
Ron, I really like that. We've had situations in the past with obviously data marts and data warehousing and that kind of deployment model where people are hoarding data. It's like, oh, that's my data. I don't want you touching my data. That this is all about how do we build a data product and then encourage people through the culture to share it throughout the enterprise, and also be, to your point, be proud of the fact that people are using their data as a core foundation.
And that's how you create a culture, right? Claudia was mentioning that. How do you get the people actually to really embrace the fact that they are now data powered? Everybody wants to have a data powered enterprise, right? But they don't have, if you don't have a clue what that actually means, being proud of your data and others are using it. And you have performance indicators, and you see, just if you have a good movie on YouTube, people look at it, watch it, and you see it, you get likes. That's the mentality that you're aiming for, and that is crucial. Then it comes to life, right? Otherwise, It's just you're hiding behind your walls, like you maybe have done in the past as well.
Yeah,
That
no, exactly.
balancing act is critical, right? Because if we over centralize the governance, then we create friction and we lose agility. So if I look at, looking at a practical engineering example, a bank that I'm working with recently, they have agreements. They have credit card agreements and mortgage agreements and direct deposit accounting agreements and so on. And we don't want to centralize the data modeling for all those agreements across all those business processes because it just takes too long. But there are a small number of attributes that we need to agree to standardize on, right? We need to agree, what does a balance amount mean and what does status mean? And it's a small number of attributes, and you promote those, I'll call it, to an enterprise schema kind of approach. But the vast majority of the attributes actually are owned by the subject matter experts in a very autonomous way, right? Because there's a whole bunch of attributes about a mortgage that are not relevant to the attributes about a credit card. And I don't want to have a discussion between the mortgage people and the credit card people about how we're going to define these different attributes and so on. So that autonomy, decentralized decision-making and ownership of the data model is really important with a really, light-handed approach to what we promote to enterprise. Those things are absolutely critical at an enterprise level to create the glue, but it doesn't have to be a complete centralization of data modeling and ownership.
Stephen, there's a question that came in here, and it's a little bit along those lines, is what is the implication to a customer around deploying a data mesh? Is there more requirements for more computational power throughout it that's going to drive incremental costs where you have more domains that need to do joining across those different domains? What's your experience, Stephen, from a cost perspective? Have data meshes cost companies more money, or they have actually saved?
Well, this comes back to the engineering approach. If you distribute everything because the teams really are not working together at all, then of course it is going to cost more money because you're moving data around. But as Ron pointed out, the technology's evolved so that what used to be prohibitive is now possible, although not zero cost, but still, the cost is coming down, and we need to recognize that, that creates new possibilities. So this is, again, back to the engineering. Data mesh can be deployed with all the schemas under all the schemas co-located, and then by definition, there's no additional cost at all. When you decide to take on additional cost, there's a reason for it. There's a reason that you need to be distributed because you've got sovereignty laws that say it's not a choice. You cannot actually take the data in Mexico and co-locate it with the data in Canada because that's breaking somebody's sovereignty laws, right? So it's not like you have a choice. And so then you have to engineer what is the best solution in a distributed environment where you minimize cost. But certainly distributed costs more than co-located, right? In most cases, it's just basic physics. But there are good reasons for distributed, right? And sometimes actually you might get more efficiency through distributed because maybe by using heterogeneous technologies, you're able to access a platform that has more efficiency for a particular kind of processing. And so you may pay more to move the data around, but you're paying less because you're using fit-for-purpose technology in order to implement. So the engineering approach has to consider these different aspects.
And let's be honest, if we talk about cost, in the end, of course, we want to create, as you started your whole presentation, Steve, and we want to create value out of data. We want the businesses to actually become data-powered and create value with that data, which they often fail to do, right? So that's in the end, of course, even if we would invest a little bit more, I believe that the payoff of having a data-driven culture, actually a business actually able to leverage data for many more purposes that they all want to do, but are sort of failing often to achieve. So what it actually delivers is dwarfs probably whatever type of investment you might have to consider.
Yeah, Ron, I think that's good. It builds well on what Stephen said, right? There could be runaway costs if you don't engineer this appropriately, but if you engineer it appropriately and you focus on the incremental value that you're getting, cost really is not a factor in it as a core component. Claudia, what do you think? From your experience in working with customers, what's the most important thing for companies to consider when deploying a data mesh? Do you have some thoughts about that?
Yeah, I do. And it's kind of a continuation of what Stephen and Ron have been talking about. One of the things that we have to, I don't like to give up on history because we're doomed to repeat it and all that good kind of stuff. One of the things that we have worked on for decades, 20 years or more, whether it was a corporate information factory or it was the bus architecture, was somehow coming up with those, as Ron mentioned, some kind of standards, whether the open standards, the enterprise standards, whatever they were, conform dimensions or MDM, master data management, tried to and in some cases has succeeded. What I don't want to see people do is throw the baby out with the bath. A lot of that wonderful enterprise intelligence needs to be maintained. There was a reason we created MDM, and we have a lot of that common data that Stephen was just talking about already mapped out. So let's promote those things. Let's make them part of the deal. If you want to join the data mesh, then here are the things that you have to sign on to and say, yes, these enterprise standards, these whatever they are, whether they're conformed dimensions or they're just simply primary and foreign key tables like an MDM or whatever it is, you're signing on to say, yes, I recognize these and I will adhere to these. And that takes a huge load off of the governance. It doesn't have to be the heavy hand saying, you're not using the right standards. So again, don't lose that. Don't throw it all out and start all over again. That's not where we want to go. Some of the other things to consider is actually the maturity of the business. I'm harking back to does the business even understand what data is all about? But I also love what Ron said, and I'm going to add on to it. The idea of a marketplace or a catalog or whatever you want to call it is that it can be a collaborative tool. People can log into it. They can see, oh, what I was just about to create is already there. And to Stephen's point, why are we reinventing the wheel over and over and over? Part of the cost and part of the skyrocketing cost is that people don't know what's out there and they keep sucking in more data instead of sharing it. They keep creating the same wheel over and over because they didn't know somebody else did. So to reduce that, we have this idea of I can find the data. Now, the other part of this marketplace is what Ron said, it's collaborative. I can give a thumbs up or a thumbs down to a report that isn't right, or that I really like this guy's work, I trust his work, I'm going to give him a certification seal or some kind of trust in him type of mark. But that collaborative conversation can be held in this marketplace so that people can say, oh, you know what? This guy always produces really trusted stuff. He really works hard. I'm going to believe in him and I'm going to use his stuff. Or this data that was used for this report is kind of iffy. It's got a lot of data quality problems. We need to mark that. We need to note that and say, if you use it at your own risk. So these are things that we've created in small amounts throughout organizations. Let's elevate those things and make sure that they are a key component. A very important part of this overall data mesh idea.
Yeah, so I think that's really, really good, Claudia. I mean, it's all about creating data products, sharing data, not hoarding data, understanding how to find data across the enterprise. So I think that ability to share is really, really important. And another question came in here, and it has to do with this idea about powerful data fabric software. And I know, Stephen, we also talk about kind of this idea of a query fabric, but can you talk a little bit about this data fabric software, and is it necessary to decide, how the query execution takes place across multiple different collections of co-located schemas? Can you comment on that?
It is absolutely necessary because the naive approach would, go figure out, okay, for the question that's being asked, where does all the data live, and then bring it all back to some centralized place and then process it all and so on. And from an engineering point of view, this is probably not optimal in most cases, right? So a smart, and that's why I call it, instead of using data fabric, I say query fabric, because I want people to think about moving the processing to the data rather than the other way around. So a smarter approach, an engineering approach, is to actually figure out where is the best place to actually process the data and do the data reduction as aggressively as possible before you move it. And, should you move from the left side to the right side or from the right side to the left side? This requires global planning to understand what are the size of the data sets. And on the target side, am I landing on the right processing engine to take the final step when I integrate the data together? So there's actually a lot of sophistication required in the software in order to do a good job in the implementation. And then beyond that, the ability to, for example, decide where is the right place to persist the data. Can I cache the data? And how many copies of cached data should I keep? And this is in part an engineering technology decision, because there's a cost of synchronizing across the caches, but there's a benefit for accessing the data. But there's also a policy decision, which is, well, maybe some data, by the nature of the sensitivity of the data, is not allowed to be cached outside of a certain geographical domain or a certain security domain. So you need to have policy-based capabilities, as well as what I'll call engineering optimization decisions. And that requires some pretty sophisticated software in order to make all that reality. Everything works beautifully on PowerPoint, but once you start moving real data around, real bits across networks and across clouds and across heterogeneous technology, then real engineering is required. And that's really about sophisticated software.
But it sounds like the whole idea of having sophisticated software around data fabric and data mesh, the concepts work very, very well together. It's just about how do you use them jointly in a focused engineering approach. So thanks for that, Stephen. Hey, Ron, how about data governance? What's the role of data governance in the implementation of a data mesh? Do you have some thoughts?
Well, I think we already agreed that the whole notion of a centralized governance needs to change, right? It needs to be more lighthearted. I think that's, we were talking about a light governance here already. So you need to strike a proper balance between understanding where the ownership actually will reside, right? And what you want to govern in terms of open standards, the platform infrastructure underneath, because I do believe you need a rock solid platform infrastructure underneath in order to enable all of this lively exchange of data products. So that's a crucial one. Open standards, and yes, metadata could be very crucial there as well. All very much more, if you look at it centrally, much more from an enabling perspective. How can I make this thing work? How can I make this ecosystem of data products, suppliers and consumers, without that dreadful big central piece in the middle, organizational governance piece in the middle? How can I make that work? And that is still, by the way, specialist work that I don't see, of course, pop up in any decentralized business domain, but it's actually really the work of what we used to have called a centralized governance as well. But it becomes different, right? I don't see it much as control. It's very much enabling. We discussed the importance of open standards, for example. It's also ways of working. It's even a cultural shift. I'm sure Claudia could say something about that as well, because you want to facilitate a change, right? Stuff like architecture is also in the end just about facilitating the changes that you foresee. And we're moving towards this. I see that for me. It's a mesh, right? So it's in all sorts of different agile ways of connecting consumers and producers of data on first class, high quality data products. And the more it's being used, the more dynamic there is, the better it is, and the more value I think is created from the organization. And the governance need to establish that. That there is a stronger part for a decentralized part of the governance is for sure, and the centralized part will definitely have other priorities to focus on.
Yeah, so we cannot ignore governance. We've got to make sure that we think about governance, but we don't want to go crazy in having too much governance as part of the data mesh concept. Stephen, there's a question that just came in. I think it would be good for you. Is the question specifically is, I get asked a lot about what is a data product. Can you please share your perspective on what makes random data show data product properties and how to best describe it?
Now, that is a great question. And the way I'd answer that is by contrasting kind of the raw material. So when I think about, for example, a data lake, what we put into a data lake is raw data. It's not been homogenized. It's not been data modeled. There are really not a lot of service levels associated with it and so on. A data product goes through I'll call it a manufacturing process to create there's value add where we're putting together the data, the raw materials from different sources. We're putting it together in a meaningful way. We've standardized certain things, and we've also committed to service levels. Data products have service levels. They have service levels in terms of performance for accessing them. They have service levels for availability. They have service levels for data freshness. They have service levels for data quality. Now, again, does that mean there needs to be a centralized governance for all products have to have exactly the same service levels? Absolutely not. Right. So we can decentralize, my data product that I'm creating aligned to my business process might be different than data product aligned to your business process, but we're each going to define what are the characteristics of that data product. So that data product, the fundamental characteristic is, making that data useful and consumable and high value, and committing to the characteristics, because a product has a set of specifications, which I would call the service levels that you expect, and you got to commit to that. Raw materials don't have that, right? And the data that you have in a data lab where you're doing prototyping and so on, again, you don't have those kind of service level commitments. So that's what I would, zoom in on the particular aspects of data product. But it's aligning to value, and to the point that Ron made earlier, it's not total cost of ownership is actually the wrong question to ask, which sounds a little bit funny, because ownership is, again, this asset. How much does it cost me to own and store the data? I actually prefer the total cost of value, right? Because that means you're consuming the product and you're creating a value from it. It's not just about storing data, it's about consuming the data. And that's why I don't like these metrics where people say, oh, I've got the lowest cost to store the data. I don't care about your cost to store the data. What is the cost to answer my business question and to create value, which of course includes storing it, but it's a much bigger picture when you look at total cost of value versus total cost of ownership.
Yeah,
and then you add the notion of product management, right, Stephen? So if a product manager looks at a product, it is how do I, get these raw materials into something that has a higher value, clearly. And so you have a vision of that. So what would be the characteristics and the qualities of the products? But you also, and I think we should not forget that, you design an experience around it. So nowadays a product manager will do, all sorts of customer journey mappings in terms of, what would be the almost emotional curve of finding out about this data product, then making the choice whether I want it, and then I'm using it. And we should realize that if we're really managing a product as a first-class asset, together with the real products, the physical products that we used to do, we need to have that mindset as well. So together with what we just discussed, I think on top of it comes a vision on how you would experience the data product, and even how you position it on a marketplace. Everything a product manager would do. How can I beat, almost, if you like, the competition by creating a more compelling experience of finding out about the product and getting compelled by it, and then I use it, and I want to be satisfied, and I come back over and over again for other products from the place where that came from, right? And that's also...
I think that's really critical. If you start looking at all the things you're talking about, I mean, a data product is just not raw data. It's something that has characteristics. It has a profile. It has SLAs. And I love what you said, Ron. It's something that has to be, managed as an ongoing product to be able to provide and drive that value. Hey, Claudia, what about your perspective on, does a business have to have certain levels of complexity to benefit from a data mesh and creating data products, or is this only for the biggest, most complex kind of companies? Do you have some thoughts on that?
Yeah, I do. And certainly, if your business is a 4-person shop, you're probably not going to need a data mesh. You can do it, and I think if the 4 are living in 4 separate parts of the United States or the world or whatever, then maybe you do want to have some kind of coordination between them, if nothing more than the enterprise standards, the open standards that we've talked about. But the more complex a business becomes, when it has multiple lines, it has thousands of employees, yeah, then a data mesh really becomes critical. If they don't have it, then they are walking down the anarchy or the chaos line. So a certain level of complexity is certainly needed. But again, that's the other thing, of course, is how do I want to put this? How centralized versus decentralized is your company in general? And I think that has something to say about this need to create a data mesh. If it's a very tightly governed business and it is very centralized and everything is all together, the data mesh becomes almost redundant at that point. So I think you need to really study the way your company is, what its personality is, where the showstoppers are going to be. If it is a very chaotic company and it likes it that way, a data mesh is going to be something that is very hard to sell. But that's you understanding your business. And of course, it always starts with, is there good executive support for this? And I'll end with that.
Yeah, but it sounds like the idea of a data mesh does help drive more value from data. And to your point, it's probably not great for really, really small companies, but any company that's dealing with an onslaught of data, that's dealing with data's in silos and you can't access data, probably has a great opportunity to think about how they might engineer a data mesh. So thanks for those comments. I've got time for one more, and I'll probably give this over to Stephen, a question that came in. It says business, including data scientists, not only need data in one place physically, but they also need to integrate data from different domains. How do you make various domains responsible in this case? So I think what they're really getting at is, there are some quote domains that are not subject level domains, they're cross-functional domains and need access to everything. Do you have any thoughts about how that might be implemented?
Well, so there's 2 aspects to that question. One aspect is I need to be able to bring the data together to do experimentation, and maybe I'm working on adding additional attributes into a feature store, something like that. So then that's where you need to be able to have a self-service capability to create your own data lab and then reach into the different schemas. And this idea of a globally accessible catalog of the data that goes across schemas, by the way, which should not be centrally managed from the content, is a point that Claudia made earlier, right? So just because we can have a collaborative catalog that allows us to see all the data, and then be able to grab the data and bring it into the R&D, the data R&D space, the data lab, whatever you want to call it. So there's that aspect of it, which is important. But then there's, let's say that I'm in a bank and I'm in treasury. Treasury in and of itself doesn't own a lot of data all by itself, but it actually needs data from all the different other business process owners. They need to be able to have access to that. Again, that global catalog is very important. They don't need to actually own the data, because the business process owners that create the data, they own the data, they own the stewardship. But now there's some certain service levels on data quality that if I'm going to consume that data product from Treasury, I need you as the business process owner to commit to those service levels, recognizing that perfection is not the goal, because perfection will never get you there. But I need to, collaborate with the different business process owners to understand what are the characteristics, or think of it as the service levels that I require for that data in terms of accessibility and availability and data quality and data freshness. I'm going to, as a consumer of that data, I'm going to negotiate with you and make sure that your service levels meet my requirements.
No, exactly. And I think that whole idea about being able to do cross-domain sharing and for experimentation and being able to execute is really critical. Well, I want to thank each of you, Ron, Stephen, Claudia. I think clearly we've made a case that when you look at engineering an approach to a data mesh, not only can it impact and improve agility for both business and technology, but really provide and elevate the value of data as a product inside of organizations. So thank you to everyone for attending our LinkedIn Live today. And for more additional information, please visit the resource link before you exit the webinar. Thanks, everybody. Have a great day.
Bye.
Bye.